Hi everyone, welcome to SmartSlides. Let's move on to a super important concept in machine learning, neural networks. The name might sound technical, but don't worry, I'll break it down into simple terms so you can understand how these powerful systems work. What is a neural network? Think of a neural network like a mini version of your brain, except it's made of code and math, not actual neurons. At its core, a neural network is a system of simple processors. Think of them as tiny workers that are all connected and working together in parallel. These processors are designed to mimic how the human brain learns and processes information. So why are neural networks special? What makes a neural network cool is its ability to learn from experiences. Just like how you learn to ride a bike by trying it out and adjusting based on what works, a neural network learns by interacting with data from its environment. Here's where the magic happens. Neural networks resemble the brain in two key ways. Learning from the environment. The network picks up knowledge through a process called learning, similar to how we do. Storing knowledge using connections. The knowledge it gains is stored in the strengths of connections between its neurons. These connections are called synaptic weights, and they determine how the network processes information. Now, how does the network actually learn? It uses something called a learning algorithm. This is just a fancy way of saying a step-by-step process that adjusts the connections, or the synaptic weights, in the network. The goal of the learning algorithm is to keep tweaking these weights until the network achieves the result it's designed for. Kind of like how you practice something over and over until you get it just right. Now that we know what neural networks are, let's talk about some of their key properties. Basically, what makes them so unique and powerful? These properties are like superpowers that help neural networks solve complex problems. 1. Nonlinearity. Neural networks are nonlinear, meaning they can solve problems that involve complex relationships. In other words, the way they process inputs and produce outputs is not a straight line. This ability to handle complex, nonlinear problems is what makes them so useful in tasks like image recognition and speech processing. 2. Input-output mapping. Neural networks are designed to take inputs like images, data, or sounds and map them to outputs, like identifying an object or making a prediction. The way the network learns this mapping is through the weights and connections between the neurons. This is what helps it understand patterns and make decisions based on new data. 3. Adaptivity. Neural networks are adaptive, meaning they can change and improve over time as they're exposed to more data. If the network makes a mistake, it can adjust its weights through learning, so it doesn't make the same mistake again. This is similar to how we adapt and learn from experience. 4. Fault tolerance. Neural networks are also fault tolerant, which means they can still work even if some parts of the network are damaged or not functioning properly. For example, if a few neurons are not working, the network can still function because it doesn't rely on just one part. It uses many neurons to process information. This makes them more reliable. 5. Uniformity of analysis and design. Finally, neural networks have uniformity of analysis and design, meaning the way they are designed and analyzed remains the same, regardless of the specific problem they are solving. Once you understand how neural networks work, you can apply the same principles to different kinds of problems, whether it's predicting stock prices or recognizing handwritten text. That's all for today's session. If you found this helpful, don't forget to like the video and subscribe to the channel.